Let's take a look at this example. In this problem, we're supposed to find, let me write this down, we have to find V1. We're supposed to find I total, see they are over here, I total. We're supposed to find resistor R2, okay, and we're supposed to find resistor R3, okay. Always start with the components which have two pieces of information, okay. So let's take a look at resistor R1, okay. Resistor R1 has two pieces of information. It has resistance, okay, 220 ohms, and it has current. So you can say that IR1 is equal 114 milliamps. 0.114 amps is equal 114 milliamps. So I got two pieces of information over here. So if I have two pieces of information, if I have current and I have resistance, I can find voltage across this resistor. Keep in mind that in parallel circuit, V1 voltage source is equal to VR1. This is also equal to VR2, and this is also equal to VR3, because all resistors in parallel circuit are connected directly to the power supply. Okay? These wires connect them directly to power supply. It means that everyone is going to have the same voltage. Okay, we don't know the voltage yet, but it's good enough that I'm going to find only one of these voltages. Automatically, this voltage is going to be the voltage of each resistor. So we have VR1. VR1 is equal IR1 times R1. Okay, so IR1 is equal 114 milliamps times R1, which is equal to 220 ohms. Okay, so VR1 is equal 114 exponent 3 negative times 220. This is equal 25.08 volts. So we can say approximately 25 volts. Okay, so V1, okay, V1 is equal to voltage VR1 is equal to voltage VR2 is equal to voltage VR3, and this is equal 25 volts. Okay, we have 25. We found V1 voltage source. Next, we can find the current which goes through this resistor, for example, right? Why? Because I have already voltage, okay, and I have already power. Okay, we have a formula which says P3 is equal IR3 times VR3. Okay, VR3. So if I will know the current, okay, I can find I total. So solve this formula for I. Divide both sides equation by VR3. VR3 and VR3 will cancel out, and you will get IR3 is equal P3 over VR3. P3 is equal 1 watt divided by VR3, which is equal 25 volts. 1 divided by 25 is equal 40 milliamps. Okay, so current which goes through resistor R3 is equal 40 milliamps. So I total in the parallel circuit is the sum of all currents in the circuit. So I have IR1 plus IR2 plus IR3, where IR1 is equal 114 milliamps. Okay, so this is the current which goes through the resistor R1. Resistor R2 has the current 58, this is 58 milliamps over here, right? So plus 58 milliamps plus current which goes through resistor R3, this is basically what we just found, is equal 40 milliamps. This is equal 114 exponent 3 negative plus 58 exponent 3 negative plus 40 exponent 3 negative. This is equal 212 milliamps. Okay, so this is total current. Okay. Next, we're supposed to find R2. Okay, R2 we are going to find by using Ohm's law. R2 is equal VR2 over IR2. VR2 is equal 25 volts because in parallel circuit the voltages are the same, over IR2 which is equal 58 milliamps. So this is equal 25 divided by 58 exponent 3 negative is equal 431.03 ohms. 431.03 ohms. We can say this is approximately 430 ohms. Okay, we found R2. Next, we're supposed to find R3. R3 is equal VR3 over IR3. So we have VR3 is equal 25 volts over IR3, which we found, and this is equal 40 milliamps. 40 milliamps. So this is equal 25 divided by 40 exponent 3 negative equals 625 ohms. Okay, so this is value of resistor R3. So we found voltage source, we found I total, we found R2, and we found R3, so we can say that the problem is solved.